Solve the equation z cubed minus 4 root 3 minus 4i equals 0. If we isolate z cubed, then we have positive 4 root 3 plus 4i. The cube root of z is the cube root of the complex number w, where w is 4 root 3 plus 4i. To find the root, we will need to use the end root of complex number, and to do that, we would need to write w in polar form, and we would need the modulus r and the argument theta, where r squared equals a squared plus b squared. In this case, a is 4 root 3 and b is 4. This is 16 times 3 plus 16, which is 48 plus 16, or 64. R is the square root of 64, or simply 8. This W is in the first quadrant because A is 4 root 3 positive and B is 4i positive. So the angle theta we're looking for is in the first quadrant, where tangent of theta is b over a, or y over x, where b is 4 and a is 4 root 3. This is 1 over root 3. We use the same trick. With tangent being 1 and root 3, we divide by 2, the top and the bottom. And since tangent is y over x, we see that the coordinate of the terminal point is x equals root 3 over 2, y is 1/2. So the angle that determines the terminal point has to be pi over 6, or 30 degrees. We will use radian in this case. With the modulus and the argument, we know that the complex number w is 8 cosine of pi over 6 plus I sine of pi over 6 with the bracket around cosine plus sine I. W to the 1/3 power is therefore the cube root of 8 cosine of theta. Theta in this case is pi over 6 plus 2k pi over n. N is 3 plus I sine of pi over 6 plus 2k pi over 3, where k are 0, 1, and 2. The cube roots, 3 solutions. With k equals 0, the first solution z sub 0 is the cube root of the modulus, which is a real number, times the quantity cosine of pi over 6 plus 2 times 0 times pi over 3 plus I sine of pi over 6 plus 2 times 0 times pi over 3. And this is 2 root 2 cosine of pi over 18 plus I sine of pi over 18. When k equals 1, the second solution z sub 1 is the cube root of 8 cosine of pi over 6 plus 2 times 1 times pi over 3 plus I sine of pi over 6 plus 2 pi over 3. This is 2 root 2 times the quantity cosine of pi over 6 plus 2 pi is pi over 6 plus 12 pi over 6, so that is 13 pi over 6 over 3 is over 18 plus I sine of 13 pi over 18. The third solution and the last solution is when k equals 2. Z sub 2 is the cube root of 8 times the quantity cosine of pi over 6 plus 2 times k, but k is 2 now, times pi over 3 plus I sine of pi over 6 plus 2 times pi over 3. This is 2 root 2 times the quantity cosine of pi over 6 plus 4 pi is 25 pi over 6. 25 pi over 6 divided by 3 is 25 pi over 18 plus I sine of 25 pi over 18. So we obtain all three solutions to the given complex equation.